All right, so the first one here, area of a triangle, this is the side angle side case. We're calculating the area of a triangle that is not necessarily a right triangle. And this proof is actually pretty easy. So we have our generic triangle. This triangle is drawn so that the angle is swept all the way through to the second quadrant, creating an obtuse triangle. Definitely not a right triangle. This purple one is not a right triangle. But we have the relationship that sine of C over here on the left, this triangle over here, sine of C is equal to opposite H over hypotenuse A. And if I solve for H, I get H equals A sine of C. So I'm going to start with basic area of a triangle, 1/2 base times height. And I'm going to replace height, which you see in red here, with A sine of C by substitution. And then I can just commute those two, and I've got my formula, 1/2 AB sine of C. So all I need to know are these two side lengths, A and B, and then angle C. And I can calculate the area of that triangle. Pretty simple proof. The other one's not very simple. Right here, Heron's formula. So this is when you have the three sides given to you. It takes all three of these identities. Law of cosines is actually an identity. It's a formula, I guess. But solve for cosine of C. The Pythagorean identity, solve for sine of C. And the area of a triangle that I just showed you, 1/2 AB sine of C. And we start by, with this formula, sine of C equals square root of 1 minus cosine squared. And then we replace cosine squared with the algebraic expression that has no trig in it for cosine. And then go from there and come up with an expression for sine of C. Then we plug that expression in for sine of C in the area of a triangle and do a whole bunch of algebra, and out pops Heron's formula down here. So lots of algebra with substitution of trig identities. That's kind of the theme in terms of coming up with these formulas, is you take some trig identities, you do a little bit of algebra, or a lot of algebra, and come up with your formula. You could actually follow through all this. We're just, here's sine of C based on this, with this inside of here, get an expression for sine of C, then put it in for sine of C here, and then do some of the algebra involved with it, a lot of simplification, factoring out difference of two squares, rearranging terms, and simplifying it down. So let's look at some examples of how to use these. So number one, you can probably tell just by the information given which area formula I'm going to use, right? Can you tell? Okay. So if you want to, you could draw a picture. Got your generic triangle here. Here's 36 degrees, that's A. This is probably the 14, that would be C. This would be B, and this would be the 10. And so I have my side angle side case. So the area is equal to 1/2 the lengths of each of the two sides, 10 times 14 times sine of 36 degrees. That's 10 times 14 times sine of 36. Plug it into your calculator. You get area equals about, just have it handy. Calculator handy. 41.1. Okay, make sure you're in degree mode and all that stuff. 41.1 square units. So that's the side angle side case. This one, number 2, you can tell already. I think I can get away with drawing about the same triangle here. So this could be 10, this could be 8, this could be 5. This is our side case. So we're going to use the semi-perimeter formula. So first I'm going to calculate the semi-perimeter. So S equals 1/2 of 8 plus 5 plus 10. That's 23. Half of 23 is 11.5. So now I have my semi-perimeter, and then you plug in that for S in the formula every time it shows up, all 4 times. So it's area equals square root of 11.5 times 11.5 minus 5, 11.5 minus 8, and 11.5 minus 10. Pop that into your calculator, and you can get the area there. We should probably check that, make sure we're doing it correctly. You can type it in your calculator just like that, or you could do the subtractions mentally and plug in just those numbers. Just gotta be careful with it. What do you guys get for the area on that? 19.8. So that's it. Area of a triangle, the 1/2 AB sine of C, and then Heron's formula using semi-perimeter and just the 3 side lengths. You know, before, what you would do, what we did back in geometry, is we dropped the altitude here. Do you remember that? Drop the altitude, call this H, and then you could use sine of 36 equals opposite over hypotenuse to find the height, and then you're just using 1/2 the base here times the height, and you're not worrying about sine of C. So what this does is integrates that step into the process. It's a pretty handy formula for those 2 types of triangles. All right, find the area of the shaded region. We did this back in geometry. We didn't have this handy formula to use to make it easier. We had to drop the altitude here and use some trig to figure that out. But if I were to draw a pictogram of what I'm doing, it's this area, that's the segment, equals the area of the pizza minus the triangle, right? The area of the segment, color code it, equals the area of the pizza minus the triangle. So I'm finding that the crust equals the whole piece of pizza minus the part that you might want to eat. My girls just eat the part without the crust. So,
You don't like the crust?
no. I make them eat it though anyways. So I'm a teacher. I make enough money to be wasting food. What's that?
Good average.
So let's go ahead and do that. Area of the pizza is going to be x degrees over 360. So we're taking some fraction of the entire area, pi r squared of the circle. Do you remember that? This is called a sector. And a sector is x degrees over 360. Or like if this were, say, 90 out of 360, it's 1/4 of the area of the whole circle, pi r squared. Minus, and then the area of the triangle, I have this fancy new formula I could use, 1/2 AB sine of C. And I know I want to use that because I have a side angle, side case here, because the other radius is going to be 12. So just plug everything in. I've got 80 over 360. I know my radius is 12. A and B are both 12. And then sine of 80 degrees. Pop all that into your calculator and figure out the area of that crust that's been wasted. What do you get? Yeah. Yeah, the negative is something like that. Yeah. 29.6 is what we should get. You want to try it one more time? Maybe I can look at what you have typed on there. If you need help, it's nice on this calculator, especially the newer ones that have the math type. You can pretty much type it in just as I've written it there. Yeah. See any issues with that? You can type it in just as you see it. is the order of operations. It's going to do all this multiplication division here. It's going to do this multiplication here, and then subtract those terms last. Should work just as you see it. All right. This last one here, number 4, says find the area of the quadrilateral. I mean, just looking at this, it's only a 4-sided shade. It should be pretty easy to do. There are actually a lot of steps to be able to do this. It's not as easy as it looks. If it were a rectangle or a trapezoid or something like that, it would be easy to do. But quadrilateral with all 4 sides different, it's a little harder. But given the angle measurement here, we can actually find it using a combination of our 2 formulas. Okay, there's actually 3 different steps this one. It uses a bunch of stuff from this unit. But there's the key. Break it into 2 triangles. All right? So the first triangle can be calculated using our 1/2 AB, which is 5 and 11, sine of 72. We'll call that area 1. So that area we can find using our new formula. So what do you get when you take that formula for the top part of the triangle here? 26.2. So that's great. Problem is we don't have an angle down here. So let's call this area 2. Do a little wishful thinking here. I wish I had this other side length, because then I could use my other new formula, Heron's formula, to find the area of that. Yeah, you're right. A lot of cosines will do it. It's a side angle side case. So to find x, I can find it by using the law of cosines, which says x equals the square root of, I don't know how you guys like to write it out. Some students like to just say, put it in the x squared form and not worry about the square root. Square roots are scary sometimes. But you know that at the end, then you're going to have to take the square root. So in its square root form, we have x equals 5 squared plus 11 squared minus 2, 5 times 11, and then cosine of 72 degrees. So you just have to, with the formulas up here, just pay attention to which trig function you're using. What is it? Okay, so about 10.6. Now I have all the information I need to calculate area 2. So area 2 equals square root of, we've got to find our semi-perimeter. Semi-perimeter equals 1/2 7 plus 8 plus 10.6, which is 25.6, half of 25.6. 12.8, right? So we got semi-perimeter of 12.8, so I pop in my semi-perimeter of 12.8, and then do a subtraction problem of 12.8 minus each of the 3 side lengths. And notice it is it's a product in here. There's no plus signs in between the parentheses or anything. And so area 2 is about equal to 28. And so the area of the quad is equal to area 1 plus area 2, which equals 26.2 plus 28, or 54.2 square units. Multi-step. I just have 3 problems for you to do. Using I think you could probably finish it in the time you have left. You have your books. Pull the books out. Piece of paper. Label it page 541, 33, 37, 42. I think you can be done before you leave.